Okay, last up for this worksheet is topic 6, where we're going to convert rectangular equations to polar equations, okay? So we need to remember a few substitutions that we have. We know this. We know x squared plus y squared is equal to r squared. We know that x is equal to r times cosine theta. We know that y is equal to r times sine of theta. We also know that tangent of theta equals y over x. So these are the substitutions that we kind of like absolutely know, okay? So we have these relationships, we may need to use them, okay? Now, when it comes to converting rectangular equations to polar equations, you generally want to look to see if you have some kind of substitution that you can use, and then you typically will try to solve for r. Now, in some cases, the equations might get like super nasty because there are situations where the rectangular equation is going to be a heck of a lot easier for us, and the polar equation is going to be just bananas. And then the opposite is true. Sometimes the polar equation is easy and the rectangular one is absolutely bananas, okay? But we still need to understand how to do these conversions. So we're going to make these substitutions, and then you sometimes set the equations equal to 0, or sometimes you solve for r. So I'm going to show you kind of like, we're going to sort of say like, hey, this is acceptable, but this is if you solve for r, okay? Now, there is a caveat to solving for r. You do have to make an assumption that r can't be equal to 0, but we'll cross that bridge when we get there, okay? So for example 7, it says convert each equation from rectangular to polar form, and we have just y equals 3. Now, you should know that y equals 3 is just a horizontal line. So if we were to look at this equation right here, we have a horizontal line through 3 on the y-axis. That's what this equation looks like to us. Let's see what it looks like as an equivalent polar equation. Okay, well, we know what y is. Okay, we have a substitution for y. Y is equal to r times sine of theta. So let's go ahead and make that substitution. We know y equals r sine theta. So we're going to say r sine theta equals 3. Okay, some people would say, hey, you've done it, stop here. Some things are going to say solve for r. So if you do need to solve for r, I want you to know how to do it. So this is acceptable. Kind of depending on who you ask, who your instructor is, what book you're using, what online homework you're using. So just kind of follow whatever you need to follow. But if you were asked to solve for R, then do it. Now you have to make sure sine of theta isn't equal to 0 here. So we are making the assumption that sine of theta is not 0. But we would divide both sides by sine of theta. So we would get R equals 3 over sine of theta. And then I could write that as 3 times 1 over sine of theta, okay? And 1 over sine of theta is cosecant theta. So you could get 3 times cosecant theta. You make the assumption that sine of theta is not 0. And, again, it depends on what book you're using, what online homework you're using. This is acceptable. R sine theta equals 3, okay? But if asked to solve for R, just know how to do that, okay? Now, for this next equation, we get y squared equals 3x, and this one is gnarly. Okay, so this one's kind of a lot. So we know what y is. We know that y is equal to r sine theta, and we know that x is equal to r cosine theta. So let's make those substitutions. So y is r sine theta, but we're squaring it. And then x is r, I have no idea what that just did. It like just created its own little geometric figure. So x is r times cosine of theta. So we get 3 times r cosine theta. Well, we do want to take care of this. R sine of theta is quantity squared. So we want r squared times sine squared theta equals 3r cosine theta. Now, what would be acceptable is to set this equal to 0. You generally want all of your r's on one side of the equation equal to something. So since we have an r over here on the right, let's scoot that whole term to the left. So we would subtract 3r cosine theta. So that would give me r squared sine squared theta minus 3r cosine theta equals 0. And this is absolutely acceptable. This is beautiful. Now, if asked to solve for R, it's a different critter. So if asked to solve for R, assuming R is not equal to 0, you have to be told that, okay? We would go right back here And we would say, okay, we have r squared sine squared theta equals 3r cosine theta. We could divide both sides by r. So divide everything by r. That would give me r sine squared theta equals 3 cosine theta. Okay. Now, if we were going to do that, we would now want to divide both sides by sine squared theta. So again, you're assuming sine squared theta is not 0. You're having to be told that r is not equal to 0. But we would get r equals 3 cosine theta over sine squared theta. All right, and that's acceptable too. So we can keep going though. We get 3 cosine theta over sine theta times 1 over sine theta. Do you remember earlier where we split up a cosine theta into just cosine theta? Well, we split up a cosine squared theta and we wrote it as cosine theta times cosine theta. We're going to do the same thing here. So this would be 3 cotangent theta times cosecant theta. Now, we had to make some assumptions here. We had to assume that we were told to solve for r and that r could not equal 0. Okay. And then we have to also assume that sine squared theta was not equal to 0. Okay. So you could take it further. Again, this is acceptable. This is acceptable. But if you're asked to solve for r, just understand that you could potentially go further. Okay. So that is converting the rectangular equations into polar form. It's nasty business sometimes. Again, there's a time and a place for both. Sometimes the rectangular form is really great. It's something we understand. It's something we love. It's something we're familiar with. It's great. Sometimes it's not. And then the polar form is much easier. So it just kind of depends. So there are times where polar is easier and makes more sense. There's going to be times where rectangular is easier and makes more sense. But it's really important to know how to convert between the two. Okay. So that wraps up this first section, 10.1. In the next section, we're going to look at polar equations and their graphs. It's going to be another really, really long section, but each piece is pretty straightforward. All right.